Hello and welcome back to SASBootcamp Week 5, Video 6. In this video, we are going to cover the exercise for this week's topic and also the homework. I'm going to describe both of these things, and then we're going to go ahead and solve today's exercise in this video as well. So let me begin by introducing the exercise to you. This exercise is close to my heart, so I'm really excited about this one. We will be using real-world data for this exercise from ATP, the Association of Tennis Professionals. So these are actual tennis data, including wins and losses for several years. I've collected data from 5 years that were played in the tennis tour from 1979, 1994, 2006, 2010, and 2015. I've picked these 5 years because each of these years is arguably the peak year for each of the 5 players that I think are contestants for the greatest of all time title, the GOAT title. So you are going to use these 5 years of data, each of which correspond to one player, to identify who is the greatest player of all time, who is the tennis GOAT, if you will. So in each of these files, there are several variables. You will see that there are more variables than you will need. But the variables that you will probably you are likely to use are tournament ID, called tourney ID, tournament name, tournament level, which is what level of tournament is this? Is it a Masters level tournament? Is it a Grand Slam tournament? Is it a Davis Cup? Is it an ATP World Tour final? Is it an ATP Tour? There are 5 levels of tournaments. What is the name of the winner for that particular match? What was the loser's name? What was the score line? What was the winner's ranking? The winner's ranking points, the loser's ranking, and the loser's ranking points. All of these things are variables you might use. There are probably some variables in here that you will not need as well. Your objective is to use these 5 data sets and to compare these 5 players in their peak year and determine who is the GOAT player. So in order to do this, you have to identify certain metrics for each player. For each player, identify the tournaments they participated in, and within each tournament level, you are required to calculate the following things: the number of matches they played, the number of matches they won, the number of match wins they have against a top 10 player, what was their overall win percentage, and average opponent rank. Remember, you have to calculate these 5 things at each tournament level, not on the whole year. So we want to know number of matches played at the Grand Slam level, number of matches played at the Masters level, number of matches played at the ATP Tour Finals level, so on and so forth. Once you've identified those metrics for each player, for each tournament level, then you will merge all 5 years of data based on the tournament level. And then you should be able to compare, for example, Federer's 2006 Grand Slam win percentage with Djokovic's Grand Slam win percentage from 2015. So to complete this objective, I encourage you to use ProcSQL wherever possible, but I'm not going to hold you to it. Use whatever you're comfortable with, and you can use data steps wherever necessary. And ideally, you're using a little bit of both in order to be achieving the best or the most optimal code solution, if you will. And if you want a little bonus points for this project, examine these data sets and please explain to me why Roger Federer is the GOAT. And no, I'm not biased at all, and I'm expecting that you will send me your answers directly on Twitter, where I can avoid you fake internet points. Thank you. Moving on to this week's homework. The homework for this week actually is the same exact homework as was provided to you in week 3. The file ndc_ph8690 was the file we used in week 3, where you had to identify a number of cardiovascular medications that go obsolete each year between 2000 and 2020. And the second objective, which was to identify which drugs were more expensive, branded or generic medications. You will have to do the same exact homework as week 3, but this time, when you read across rows, I encourage you to use ProcSQL with a group by statement instead of using retain commands with the first dot and last dot variables. If you do that, this will be the same exact homework. I'm going to pause here long enough that you can pause this video, take a screenshot, go attempt the homework. Please try to do that for the exercise as well. I think this is one of the most exciting exercises that I've planned. So I hope you have fun. Pause the video, take a screenshot of what's on screen right now, and then you can come back and I will tell you the solution for the exercise. All right. I hope that's enough. That's enough of a pause. I'm going to switch gears now and jump straight into SAS Studio so we can look at the actual data sets we will be working on. Okay, so hopefully you should be able to see my screen on SAS Studio right now. I'm going to open my data set from the ATP 1979 data set, examine the variables, and then we can get started with the homework, with the exercise, excuse me. So here are all the variables that are in the data set. And by the way, this is all real data. You can go look up 1979's matches and you will see that these matches actually happen. So there is a tournament ID which tells you what is the ID. It's a numeric ID for the tournament. The name of the tournament, for example, this was the Australian Open, which was played on grass back in 1979, which, by the way, if it was still played on grass, Roger Federer would have 10 of those tournaments. Tournament level is G, which stands for Grand Slam. If you scroll, you will see A, which is ATP Tour, and some other categories. The date on which the tournament occurred, the match number, which is basically a match ID, if you will. There is a winner ID. This ID field is actually unique to each player. You are welcome to use it, but you don't have to. Winner seed, winner entry, we are going to ignore that. Winner name is the name of the player. So each match has a winner and a loser. Winner name is the name of the winner in that match, whether they were left-handed or right-handed. Some other variables that I'm going to ignore here. And then there is a loser name. And then the other variables that we are concerned with are towards the end here. Let me see if I can get those to display. Oh, no, I need to see if I can get the right variables to display. Okay, loser rank and winner rank. These are two variables we are interested in. There are several other variables here, but I'm not going to describe them because we are not going to need those for this project, for this exercise. Okay, so winner rank and loser rank basically tells you what was the rank of the player. All ATP players are ranked beginning from 1 all the way to as many players there are, right? So this tells you the rank, and rank is a way to identify how good the player is coming into that match for the past year or so, because rankings get reset every 2 years, really. Whether or not you know how tennis works, hopefully that should be enough information for you to get started on this exercise. But if you don't know how tennis works, feel free to explore that data set a little more. Go through what the variables are, go through what those values are, and you are welcome to Google some of those matches that happened, for example, in Australian Open in 1979 to identify what you need to do. Having said that, let us jump straight into this week's exercise. So how would you even approach a problem like this? Well, the way I would approach a problem like this is I would first identify what are the metrics we need to calculate for from each data set, right? The metrics are number of matches played, number of matches won, and then there's a win percentage, which should just be number of matches won divided by number of matches played. We also need to calculate number of match wins against a top 10 player, and then we need to calculate average opponent rank. So all 5 of these things need to be calculated. So first thing I want to do is before I can do, remember these 5 metrics need to be calculated for each group level, each tournament level, whether the tournament level is a G, M, A, F, or whatever it is, right? So before I can do my group by, to get those 5 variables, I first need to build the variables to get my summary functions there. So the first thing I want to do is I want to take my ATP 1979 data set and then subset from that data set to get exactly what I'm looking for, right? So let me show you how I would do that. I'm going to take the 1979 data set, create a new file called, Borg_matches, and I'm going to set my ATP 1979 data set here. Okay, next what I want to do is I want to say, let me create some flag variables. These flag variables are the variables that I am going to be manipulating to calculate those 5 summary statistics we spoke about. The flag variables I'm interested in are a win variable, which I'm going to set to 0 for all the rows first, and a top 10 win variable, which I'm also going to set to a 0 for everything. And then we will manipulate these things in a little bit. The first thing I want to do though is I do want to manipulate those flag variables, but I also want to make sure that I only hold on to rows where Bjorn Borg, who is the player of interest in the 1979 year, that all the matches I'm holding on to are Bjorn Borg's matches. Because if I have matches where Bjorn Borg was not playing, that doesn't help me towards the metric of number of matches Bjorn Borg played, or number of matches he won, or number of match wins against a top 10 player. I only want to hold on to the rows of data where Bjorn was either a winner or a loser. So let me go ahead and do that first. So I want to say if lowercase winner name is not equal to Bjorn Borg. By the way, supremely underrated player. It's a pity he retired when he did, because if he had played longer, I think he would have a much better argument in today's GOAT debate. But don't let me get carried away, because I could talk about this all day. Okay, so this is my command for deleting all the rows of data where Bjorn Borg was not a player. I'm saying if the winner name was not Bjorn Borg and if loser name was not Bjorn Borg. Basically, if Bjorn Borg is not the winner and the loser, then Bjorn Borg was not playing that match. I don't care about that match. But if the winner was Bjorn Borg, then I want to set up my flag variables now. Equals Bjorn Borg. Remember, I'm using the lowercase operator just to be safe with my programming. If the winner was Bjorn Borg, then win equals 1. And if the loser's rank is actually less than the top 10, if they're in the top 10, then top 10 win equals 1. Right? So if Borg won the match, then it's a win. And if Borg won against somebody that was ranked in the top 10, then it's a top 10 win. Other things I want to do, I want to make sure that there is a variable for opponent rank. Opponent rank equals loser rank, which I actually need to create a flag variable for opponent rank as well. The opponent's rank in this case, because Borg won the match, the opponent's rank is the loser's rank. And I'm also going to create an additional variable called player, where I'm just going to set it equal to his name. Then I want to do the same things for when Borg lost a match. So if lowercase loser name equals Bjorn Borg, then I want to set win equals 0. I want to set I want to say if the winner's rank, because this is a match he lost, if winner's rank is less than 10, then top 10 win equals 0. And the opponent rank is going to be equal to winner rank in this case, because Bjorn was the loser. And that should be everything I need. Now, before I wrap up, while I have all of my variables here, I do want to create a unique match ID variable. The way the data set is set up, this is where you need to think about how you want to count your matches, right? There is a tournament ID, but that tournament ID repeats, because for example, look at all these matches played at Auckland, right? The Auckland tournament ID is the same, which means this is a repeating number. There is also match ID or match number, but match number is also repeating, because you can see here that it just increments from 1 through however many matches in the tournament and then sets back to 1 for the next tournament. So if I want a match ID, I need to have I need to know both tournament ID and match number, and together I can identify a unique match that occurred at a tournament. So I'm going to create a unique match ID variable. Excuse me. I'm going to create a unique match ID variable. I'm going to say match ID equals I want to concatenate my tournament ID variable with my match number variable. But before I concatenate them, I also want to make sure this match ID is legible. So I'm going to add a little separator in between those two things. A simple hyphen will do for our case. Okay, so this is all we need. But then I also want to delete all the other variables that I'm not interested in. So I'm going to hold on to some of the key variables. I want tourney level, which is the Grand Slam or a Masters level tournament. What was the level of the tournament that was going on? I want to hold on to the match ID variable that I just created. I want to hold on to player name, and then my flag variables that I created. That should be it. So let's run this, see what the data set looks like. Okay, let me check my log. Looks like there is a warning. Variable tourney level has never been referenced. That's because I have a typo there. There's no U in tourney. Well, not there. I'm going to check my log again. Log looks good this time. Borg played 80 matches. Out of the 4,000 matches that happened in 1979, Borg only played 80. And really, 80 is a lot. In these days, most tennis players don't play 80 matches. Anyway, you can see here, there are 80 rows, and you can see that the tournament level is the first one. A stands for ATP Tour level tournament. G means Grand Slam. D means Davis Cup. M means Masters level, so on and so forth. And for each tournament level, we know whether they won, 0 or 1, whether it was a top 10 win or not. So top 10 win would be 0 if they lost to a top 10 player, 1 if they won against a top 10 level player. Opponent rank is 4. Player's name is Bjorn Borg, which should be the same for all the rows in our data set. And the unique match ID, which is a numeric unique number that we created to help us out, to help us calculate how many matches we are played. Okay, so now let's roll this up to a tournament level. Which means we want to be using summary functions, and we want to calculate those 5 summary statistics that we mentioned at the beginning of this exercise. Now, if you want to roll this up, you can use, you can sort the data set by tourney level, and because tourney level is the group or the bucket of choice, you can use retain statements with first dot and last dot variables. But really, the purpose of this week was to do this with proc SQL, not with the data step. So I am going to write a proc SQL command to do this. Right. I'm going to create a new table called Borg_data, and I need several variables in here. But before I type my variables, let me finish the rest of my proc SQL step. I want this data set to be built from the Borg_matches data set, and I want it to group by tourney level. Okay, so that's my group statement. That's all I need to say. I don't need to sort my data set before, and I've mentioned what my grouping or my bucket variable is. Now I need to write what variables I want in my select statement. Remember, in a select statement for a proc SQL with a group by command, you are only allowed to have 2 types of variables. The first is the grouping variable itself, which in this case is tourney level. So I'm going to write that exactly as it is. And then all the other variables in the select statement have to be summary level variables only. I can't have any non-summary variables. So what are the summary variables I need? We talked about 5 variables from the exercise's objective, right? Number of matches, number of wins, number of top 10 wins, average opponent rank, and win percentage. That last one, win percentage, I'm going to calculate that later and not worry about doing that within the proc SQL. So let's do the other 4. First one we want to do is count number of matches, right? I'm going to use a simple count function. I'm going to count match ID as number of matches. So that will say how many rows are present within each tournament level, which is my grouping variable. And it's going to count the number of rows, and it's going to save that in a variable called number of matches. Next, I'm going to use a sum function on the win variable to count number of victories. Right, that's just going to take a sum of number of wins, because that win column basically had a 1 every time Borg won a match. Next, I'm also going to do the same thing for my other flag variable, top 10 win. I'm going to save that as total_top 10 wins. And then I have the average opponent rank. So I'm going to take the average function on the opponent rank variable, and I'm going to save it into a variable called average opponent rank. Right? This should give me all the statistics I need except win percentage. We'll talk about how to get that one later. Check my log. Here's my output. There it is. We've reduced our 4,000 rows of data from the 1979 dataset down to 4 rows, which shows us Bjorn Borg's performance in 4 levels of tournament. A is ATP tournament, which is the lowest level of matches you can play. D is Davis Cup. Davis Cup, if you don't know tennis, is a country level tournament. It's played against countries as opposed to players against players. G is Grand Slams, which is the highest level of tournament you can play in. And Masters is M, which is the second highest level of tournament you can play in. For each level, I know how many matches were played, how many of those matches were victories. So for example, at the ATP Tour in 1979, Borg won 53 out of all 53 matches he played. How impressive is that, huh? At the Davis Cup level, he won every single match again. At the Grand Slam level, he won every single match. Some of these were top 10 wins. For example, of the 53, 12 were top 10 wins. Of the 3 matches here, 1 was a top 10 win. And here is average opponent rank that you need to see for each individual tournament level. Give me just a second while I confirm that these numbers are correct. I programmed this earlier on my own end in SAS just to help speed up this process, and I think I've got it right. Next, what I want to do is, the way I've calculated data for Bjorn Borg, I want to do the same exact thing for all 5 years of data, all 5 players. So I'm just going to copy and paste Bjorn Borg's data into my remaining code to do this for Pete Sampras, Roger Federer, Rafael Nadal, and Novak Djokovic. Instead of copying and typing all of this on the video right now, I've actually written this code earlier. So I'm just going to copy this, and I'll walk you through the code after I paste it into our exercise file. Okay. So let's walk through the code here. So this was Bjorn Borg's data, which we looked at that data set. Next, we want to do this for Pete Sampras, Pistol Pete from 1994. So I've called the data set pistol_matches, and I'm doing the same exact thing I did with Bjorn Borg, which is I'm identifying when Pete Sampras was the winner, and I'm setting my flag variables accordingly. I'm identifying when Pete was the loser, and I set the flag variables accordingly. I'm deleting all matches where Pete Sampras was not a player, where he was not a winner or not a loser. I'm creating a unique match identifier, and then I'm keeping the variables I want. And then I'm using the group by statement. I'm using the group by statement within this data set from pistol matches to create a new data set called pistol data, where we have the grouping variable here, tourney level, and then we have a bunch of summary variables which give us the statistics that we are interested in. So let me run these 2 pieces of code and see if this works. Log looks okay. Output data set. Let me go to pistol_data. There you go. This is for Pete Sampras. Pete, super great player, played 5 levels of tournaments, because when Bjorg was playing in 1979, the F level of tournament, which is ATP Tour Finals, was not really around. It started much later, so Pistol Pete actually got to play in it. And in 1994, Pistol Pete did not win. I think he went to the Grand Slam. He went to the final of that tournament and lost there. So there you have 4 victories out of 5 possible matches, and all 4 victories were against top 10 players, because that tournament is only played for the top 10, top 8 actually. I'm digressing into my tennis conversation here. Let me focus, get back to doing the same thing again, this time for Roger Federer. Got my by variable in my by option, my group by statement missing. I'm just going to run this. We'll look at the data for Roger Federer, and then do the same for the next 2 players as well. Okay, here's Roger Federer's data. He played in 5 levels of tournaments. All the numbers are right here. Next, we want to do that for Rafael Nadal. Okay, so Rafael Nadal, 5 levels of tournaments, and all numbers are here, looking good. Next, we want to do this for Novak Djokovic for the year 2015. And by the way, there is some controversy around which is the best year for these players. Some people think 2007 is Roger's best year. Some people think 2011 is Joker's best year, but we are going to stay out of that debate for the purpose of this exercise. If you are interested, we can have this conversation online after this class's video. Okay. Next, what we want to do is, now that we've summarized data from all 5 years for all 5 players, we want to merge all these data into one file so that we can actually compare across different players. So to do the merge, we can use a data step. We can use the merge command within a data step, but I want to use the proc SQL because that's what this week's topic is all about. So I'm going to write proc SQL, create table all players data as select, and I'm going to write my select statement at the end, and I'm going to start with my from statement. My from statement, I want to basically merge these 5 data sets together, right? Borg data, Joker data, Fed data, Pistol data, Rafa data. Let's begin with writing Borg data. So Borg_data as A, and I want to write as A because I want a shortcut for referring to Borg data later, and I don't want to type Borg_data every time. And I'm going to use my left join because that's what I'm comfortable using. You're welcome to use an inner join, an outer join, anything doesn't matter in this case, because all the data sets should be 1:1 merges, right? There shouldn't be any missing values, except for the fact that Borg only played in 4 levels of tournaments, but all the other players played in 5 levels of tournament. So let me go ahead and use outer join here. Now that I mentioned that, I realize this is probably going to be important. Okay, I'm going to do an outer join with, let me do this with pistol data. And I want to do this join on a.tourney level equals b.tourney level, because we want to merge at the tournament level in order to do the right comparison. Now let me go ahead and complete my select statement. In my select statement, I want to write my grouping variable first, right? And there is no grouping variable here, but I do want to write the key variable as my quote unquote grouping variable in this case. So I want to write tourney level, but I'm not actually going to pull this from the A data set. I'm going to pull it from the B data set, because I know that tourney level is missing for Borg because he didn't play in an ATP Tour final. The F tourney level, he didn't play in it. So I'm going to pull that from the B data set, which is pistol_data. And then now I need to start pulling all the variables from each data set. Now the data sets for each, the variables for each data set actually are all the same name, which gets really confusing. So I want to rename those variables as I can. So for example, there is a number of matches variable. If I'm pulling that from the A data set, that's actually number of matches for Borg. So I'm going to call that Borg_num matches, right? And then I've got a variable called num victories. If I'm pulling that from the A data set, I know the victories belong to Borg, so I'm going to call that Borg_wins. Then if I'm doing the total top wins variable from the A data set, I know that is for Borg, so I'm going to call this Borg_top 10 wins. And then finally the average rank variable, which is going to be Borg_average opponent rank. And then I want to do the same thing for the variables from the B data set, except this time they're going to be named after Pistol Pete. So pistol number matches, pistols wins, excuse me. Okay, so I know I need to merge all 5 data sets eventually, but for now I'm just going to do 2 data sets, and I'm going to see how this works. If it works well, then I can go ahead to do the other 3, excuse me. I've got a typo here. That is because I just need to do, what am I looking at here? Give me a second. To do an outer join, I need to write the word full join, not outer join. That was my error, excuse me. Okay. An outer join is actually called a full join in ProcSQL. Check my log, 5 rows. Okay, so I've got tourney level, which came from the pistol data set, not the Borg data, because you know tourney level was missing for Borg. He didn't play in the F level tournament. Tourney level F was missing. So there you see missing values for Borg. And then for Pistol Pete, we have all the numbers from all 4 variables that we merged on. So this works well, except now we are doing this with 2 data sets. I want to do it with all 5 data sets. So if you want to merge on all 5 data sets, really you can write 3 more ProcSQL merge steps like this, but it's also possible to do all of those merges really in just one ProcSQL step. So if you want to do that in one ProcSQL step, the simple way to do it is to just write multiple full joins back to back. So Excuse me. So here we joined borg data to pistol data on a full join. Now we are going to take that data set and full join it with fed underscore data, which I'm now referring to as C on a.tourney level equals c.tourney level. Right? And that should be it for adding the third data set. Except now we have to add variables from the third data set into our select statement. So I'm going to do that. These variables should be named after Federer. So I'm going to call them Fed matches, Fed top 10 wins, Fed wins, and Fed average opponent rank. Let's see if this works, and then I will add the other two rows of data in here as well. Okay, so we've got some issues going on here. Excuse me. We've got some issues going on here, and I think I know exactly why. So what is happening is we know, for example, that Borg did not play an F-level tournament. So that F-level tournament is missing for Borg, right? And Pistol Pete has it. But it is also missing for Federer, but we know Federer did not miss playing an F-level tournament. He actually did play the F-level tournament. In fact, in 2006, he won that tournament, and that is this row of data. How do I know it's this row? Because that row is missing for both Pistol Pete and for Bjorn Borg, and the tourney level variable is missing here. That is happening because when I did my merge to Fed data, I merged tourney level A with tourney level C. The tourney level A had missing value for F, right? There was no value of F. That also happened in this row here, but here, because we are using B.tourney level, that didn't matter. So the simple way to fix this is to just write B.tourney level. So you're matching tourney level in the Fed data to the value of tourney level in the B data set, which is pistol data, which is actually the tourney level in the overall final data set. So let me change this A to a B and see if this works better. If this gets confusing, please feel free to use data steps to do your merge, or the easier solution in my mind is to merge two data sets at a time. So write one proc SQL with a full join statement for the first two data sets, and then take the output of those two data sets in a separate proc SQL statement and merge it with the third data set. Then take the output of those two data sets and write a separate proc SQL statement for the next data set. That you can do that, and that's a little more intuitive, easier to understand, and less risky in terms of making errors. But I want to show you how you can do all of these joins within one proc SQL. So I will continue to stay with this code here. Next, we want to merge with Rafa data on B.tourney level equals D.tourney level. And I'm going to go ahead and also do Joker data. Okay. Now, I also need to add variable names. I'm not going to bother typing it. I'm just going to, because I've written this before, I'm just going to copy and paste that code. Please excuse my laziness here. Okay, so I've done the same thing here. I've written the names of the variables from the fourth dataset and the fifth dataset, renamed them after the player that dataset represents. So the fourth dataset is all Rafa's data, Rafael Nadal. The fifth dataset is Joker's data, which is Novak Djokovic. So I've renamed those variables, and I've got all my full join statements written here. Let me run this, see if my code works. All right, my log looks good, 5 rows of data. Look at my output. Output is looking great as well. Okay, I think. Let me see. We may have a problem. Why are there missing rows here? Let me go back. Did Joker not have F-level tournaments? I need to verify this. Yeah, I guess Joker did not play in in F-level tournaments, just like Borg did not. Okay. So that explains why there is missing values for Joker. Let me go back out to data. So Borg did not play in the F-level tournament, but neither did Novak Djokovic. In 2006, I think, in 2015, he must not have played. Perhaps he was injured. I cannot remember what happened to him that year. Well, anyway, the rest of the row and the rest of the columns are looking good. So we've got all of the metrics the four metrics. Matches, and average rank for each player towards each other at the tournament level of game. The last thing we need to do is we need to calculate the win percentage. And then we need to compare our players against each other. So let's do this. Time for both data. Example, set all the data. So we calculate win percentage based on matches really. It's just a numerator that is the denominator. So let me go with that. So the percentages should not be actually the that calculation 5 times for the 5 players. So the next one will be Pistol, and then Federer, Rafa, and Joker. Let me rename my other variables as well. And that should be all I need. When I run this, it should give me my final data set. Excuse me, I guess I have an error here. Oh, I am missing a parentheses. I'm sorry. There you go. Okay, I'm missing a parentheses because this parentheses covers the numerator and denominator, and then I need one parentheses for the round function itself. Oh, I still have an error. Work all player data does not exist. Did I call that something else? All players data. Plurals always coming to get you. Okay. Check my log. Log looks good. Go to my output data. And here are all the rows of data followed by win percentages for everybody, right? So now you have enough information to do your own comparisons across these 5 players at their peak performance to decide who's the greatest of all players. So please look at this data and all the other columns in this data set. Please come to your own independent conclusions, unbiased independent conclusions about why Federer is the greatest player of all time, and tweet at me and let me know why I'm correct. Thank you. That concludes this week's exercise. I will upload a version of this code with all of my comments included to the class folder in SAS Studio, so you will have access to the responses. If you have any questions about ProcSQL, please reach out to me. Otherwise, I will see you guys on Friday to discuss this week's homework.